Welcome to 6.2. Today we're talking about circumcenters and incenters. And what's important to note about circumcenters and incenters is two different things here. Circumcenters are perpendicular bisectors that meet at a point. And that point can either be on the inside, or it can be on the triangle, which is a right triangle, or it's going to be on the outside if you have an obtuse angle in your triangle. So circumcenters, you find those points by doing perpendicular bisectors. So notice you have two segments that are the same, two segments that are the same, and two segments over here that are the same. So a circumcenter is made by doing perpendicular bisectors. That's what you need to remember. Okay, so remember, perpendicular bisectors make circumcenters. And you know what a perpendicular is, and you know what a bisector is. The next thing we want to do is talk about the incenter. The incenter is formed by angle bisectors. Okay, so angle bisectors. You know what an angle is, you know what a bisector is. We just got done doing a lesson over both of those. Okay, so if you have an angle bisector, that leads you to a point. They all meet at a point, and those points are equidistant to this side of a triangle. Those are not perpendicular bisectors, they're just perpendicular. Notice that this side is not, that length is not the same as FC. AF is not equal to FC. So angle bisectors meet at a point, and that is your incenter, equidistant to the sides of a triangle. And perpendicular bisectors make your circumcenter. Okay, so perpendicular bisectors, we're talking about circumcenters here. All right, so perpendicular bisectors, you need to automatically start to think what we're talking about, circumcenters. All right, so perpendicular bisectors meet at a point, and they separate the segments into equal segments. And they make right triangles. That's the other thing. Use Pythagorean theorem to find some of the lengths. So find the indicated measure. All right. We want to find BG. So the length of BG. Notice there's no segment bar above it, so we're talking about the distance. B to G. And circumcenters are equidistant to the vertices. Not only do they bisect the outside pieces of the triangle, the legs of a triangle, they're equidistant to the vertices. So they are radii. So circumcenters are radii. All right, so that means that BG and AG and GC are all the same. All right, so BG must be 9 because AG is 9. Okay, again, now we look at number 2. It's on the outside, so we have an obtuse triangle. Just pointing that out. So if FC is 9, then CF is 9 because the circumcenter point comes from perpendicular bisectors. All right, perpendicular bisectors. So those two are the same, these two are the same, and these two are the same. Okay, so GA is a radii. Remember, the circumcenter is also a radius. So GA and GB and GC are all radii in the circle. So if GC is 11, then GA is 11. Okay, number 3, you and 2 friends plan to walk your dogs together. You want the meeting place to be the same distance from each person's residence. Explain how you can use the diagram to locate the meeting place. So you want to be equidistant from the vertices of a triangle. So from the vertices, that would be your circumcenter. Okay, so you would need to draw a circumcenter by doing perpendicular bisectors. So we're going to freehand perpendicular bisector here. We're going to freehand this one, okay, and we'll freehand this one. And my guess is this is probably a right triangle, and that should be on the triangle. I didn't draw a perfect triangle. Okay, but that's explaining what you would do. Explain how you'd use a diagram to locate the meeting place. So you would take out a map and construct perpendicular bisectors, and you would find out where you need to meet, because that would be equidistant to the vertices of the triangle. Number 4, you open a donation center the same distance from each of the 3 stores shown. Okay, use the diagram to determine the location of the donation center. All right, so let's see if I can draw perfect lines here. Okay, so there's your vertices connected. Again, I'm just going to freehand where I think the perpendicular bisector is. Okay, and so right there's your circumcenter, and that would be equidistant to the 3 stores. Okay, so there's your location of your donation center. Okay, angle bisectors. Remember, angle bisectors are incenters. Now I want you to understand this. Incenters are always inside the triangle. They're equidistant from the sides of the triangle. So AP and PB and PC are all the same. HP and number 6, PK and PF are all the same. But again, they make right triangles. You can always use Pythagorean theorem to figure out certain things. Okay, now they're also angle bisectors. That's what an incenter is. So we know these 2 angles, those 2 angles are the same, and these 2 angles are the same. All right, so what is PB? There we're talking about distance. So PB is not 15, okay? 15 is the length from P to Z. PC is 9, which is the same as PB and PA. So that would be 9. All right, HP is the same as PK, which is 15. All right, number 7. Okay, so now we gotta draw all of these. Okay, so number 7. And do 0, 0 is A. 0, 8 is going to be B. I'm going to go by 2s. 1, 2, 3, 4, 5, 6, 7, 8. And 6, 0. 1, 2, 3, 4, 5, 6 is C. So since it's a right triangle, circumcenters are going to be on the right triangles. So I know it's going to be on one of these sides. So this is a right triangle. Remember, circumcenters are perpendicular bisectors. So AC is 6 units long, so this is going to go through at 1, 2, 3. Let's do this in blue. It's going to go halfway up here. And AB is 8 units long, so it's going to go through at 0, 4. It's a right triangle. And you'd have to get the midpoint of BC, but we already know in a right triangle, the circumcenters are on the hypotenuse. So I know that's where that perpendicular bisector is going to be. Okay? The other thing is BC is down 8 and over 6. Down 8 and over 6. So the perpendicular would be positive 6 over 8. So from that point, I can go up 6 and over 8 if I wanted to. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And that would give me a straighter line that is a perpendicular bisector if I needed to. All right, number 8, we're going to do the exact same thing again. 2, 2, 2, 4, and 8, 4. Okay, and we're going to go by 2s. All right, so, that coordinate, we're supposed to get that. So that is at 3, 4. That's the circumcenter. All right, now number 8, 2, 2, 1, 2, 1, 2. 2, 4, 3, 4. And 8, 4. So this is A, B. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Again, this is a right triangle. So I know it's going to be right here somewhere. All right, so let's split AB into 2 equal pieces. Okay, so that's a perpendicular bisector. Let's split BC. So 1, 2, 3, 4, 5, 6. So it's at 3. 1, 2, 3. right here is a perpendicular bisector. So at, let's see, that's where that's supposed to be at. So 1, 2, 3, 4, 5, 3. 5, 3 is where the circumcenter is at. So just draw, on a right triangle it's pretty easy. Just draw two perpendicular bisectors and it's going to be on your hypotenuse. All right, let's do this one. Okay, so again, we got to do the circumcenter. Negative 10, 7. So I'm going to go by twos again. 1, 2, 4, 6, 8, 10, and up 7. 1, 2, 3, 4, 5, 6, 7. So there's H. Negative 6, 2, 4, 6, and up 3. 1, 2, 3 is J. And negative 2, 3 is K. All right, so it's an obtuse angle. So the circumcenter is going to be on the outside. So here's how we're going to do this. We got to find at least two perpendicular bisectors and see where they meet. So JK is obvious. Here is the midpoint of JK. That will be the bisector, and perpendicular means, let's do these in blue. It's going to be straight up and down because JK is horizontal. Okay. Now I'm going to use HJ. I need the midpoint and the slope of JH. So the slope of JH is coming from 7 down to 3, so that's negative 4. Negative 4, and then it's going, let's see, 1, 2, 3, 4, and over 1, 2, 3, 4. So negative 1 is that slope. The perpendicular to that would be positive 1. But we need to start somewhere for rise over run, so we need to find its midpoint. So HJ's midpoint is going to be, add the two together, H and J, negative 10 and negative 6, divided by 2, and 7 and 3 divided by 2. So that's going to be negative 16 over 2, or negative 8, and 10 over 2 is 5. So negative 8 is right there, and up 5. 1, 2, 3, 4, 5. I'm sorry, this is negative 8. 1, 2, 3, 4, 5. Okay. So it's halfway in between here. There's your 5. Okay, now from there we go up 1 and over 1. So up 1, over 1, up 1, over 1, up 1, over 1. So because I freehanded all of this, it doesn't look like it's hitting at the right spot. This is going to be way up here. If it was drawn right, that would look right. So where do these meet? How you do this is use your slopes. Up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. And wherever they meet, if you're using your rise over run, you'll find it. So that's your circumcenter. Let's go on to number 10. Again, we're going to draw all this out. So 3, negative 6, 1, 2, 3, 1, 2, 3, 4, 5, 6 is L. And then 5, negative 3, 4, 5. Oops. 5, negative 3. It's right there. That's going to be M. And 8, negative 6. 6, 7, 8, and negative 6 will be N. All right. So now we need to find midpoints. So let's use the horizontal line here, LN. And that's easy to find the midpoint. So 1, 2, 3, 4, 5 units long. So it's going to be in between those at 2.5. Wow. So 1, 2.5. So that is at 5.5. 5.5 is the X. And all the way down to negative 6. Okay, so that's the midpoint there. And if I just draw that straight up, that is the perpendicular bisector. Okay? And now I need the midpoint from M to L. So midpoint of ML. So add those together, 3 plus 5 over 2, and negative 6 plus negative 3 over 2. So that's 8 over 2 is 4, and negative 9 over 2 is negative 4.5. So at 4, 1, 2, 3, 4, and down 4.5. 1, 2, 3, 4.5. There. Now, how do I draw this? Is I need the slope of ML is going to be rise over run. So 1, 2, 3, and over, say up 3 and over 1, 2. So 3/2, so the perpendicular slope is negative 2/3. So from my midpoint, I go down 2. So 1, 2, and over 3. 1, 2, 3. And it's hard to tell exactly where they meet. I'm pretty sure I didn't draw this straight. It should be right here, because I think this is a right triangle. So that point is at 5.5 and negative 6. So that would be my incenter there. All right, number 11. I meant that was circumcenter. Now we're doing incenter. So incenters are angle bisectors. So where they meet is equidistant to the sides of the triangle. So ND is 6x minus 2, and NE is 3x plus 7. So those are both equal to each other. So we set those equal to each other, and we solve. So subtract 3x, and they get 3x minus 2 equals 7. And add 2, 3x equals 9, divided by 3 is 3. So x is 3. It wants NF. NF is the distance. So we got to plug 3 in. So all three of these are the same, NF, NE, and ND. So just plug 3 in for one of those. So we'll say it's the same as NE, which is 3x plus 7. So 3 times 3 plus 7 is 9 plus 7 is 16. So the answer is 16. Number 12. Again, all of these distances are the same, NH, NG, and NJ. So we set these equal. X plus 3 is equal to 2x minus 3, because those are your sides. From the incenter to the sides. So subtract x, we get 3 equals x minus 3, we add 3, and x is 6. So plug it back into one of them. So x plus 3 is the same as nj. So 6 plus 3 is nj. So 9 is the answer for number 12. All right, so now we're looking at these. Nk is 2x minus 2. Nl, so these are the same. This is the same as the last one. So the incenters, they're equidistant. And we have to find the length from end to end. So 2x minus 2 is equal to negative x plus 10. Add x. 3x minus 2 is equal to 10. Add 2. 3x is equal to 12. Divide by 3, and x is 4. So that's what x is, but we got to find nm, which is the same as either of these two expressions. So 2x minus 2, I'll just use the top one. 2x minus 2, 8 minus 2 is 6. That would be nm. And same thing over here, nq and nr, they're the same. So 2x is equal to 3x minus 2. So I'll subtract 3x to the left. It gives me negative x equals negative 2. Don't drop the minus sign. So a negative x equals negative 2, so positive x is positive 2. And again, nq is 2x, and that's the same thing as ns. So substitute your 2 in, and you get 4 equals ns. That's the answer to 14. Number 15. This is a circumcenter, so these are perpendicular bisectors. Px, here's your circumcenter. It is equidistant to the corners, so all of these are radii. I say radii because this is a circle. All right. All right, so px is the same as py. 3x plus 2 is equal to 4x minus 8. Subtract 3x. You get 2 is equal to x minus 8. Add 8. 8. 10 is equal to x. So it wants to know pz, which all those are the same. So 3x plus 2 is the same thing, equals pz. So 30 plus 2 is equal to pz. So 32 is my answer from p to z. 16. Circumcenter again. Those are all the same length, so px and pz are the same. We'll have to find py, that length there. So set them equal. 4x plus 3 is equal to 6x minus 11. And you get 3 equals 2x minus 11. Add 11. 14 is equal to 2x. Divide off the 2. X is equal to 7. So just pick one of those expressions. 4x plus 3. 28 plus 3 is 31. All right, what'd they do wrong? So let's see here. We have angle bisectors, so this is an incenter problem. And incenters are equidistant to the sides of your triangles. But we don't have perpendiculars here. So what I'm saying is that would be the same thing as those right there. This one looks like it's a perpendicular, but we're not sure. So it's not asking for that. It says GD, this one right here. So let me take off those other ones there. GD is equal to GF. Okay, so that's what they did wrong. They need to be perpendicular to the sides, and they're not. These are just the angle bisectors extended through the side. So again, the perpendicular would be right there. So that's not GD. So they confuse GD with a perpendicular bisector or a perpendicular line. Number 26. Here we have perpendicular bisectors. So this is a circumcenter, and circumcenters are equidistant to the corners of the triangle. So all those blue lines are the same. So it says TV is equal to TZ. Okay, so what they've done here is they've switched the meaning of both incenter and circumcenters. So that's what you need to explain. 27, you're placing a fountain in a triangular koi pound. You want the fountain to be the same distance from each side. So the same distance from each side means incenter. So you need angle bisectors. So should the fountain be at the circumcenter or incenter? Incenter, because incenters are equidistant from the sides. All right, next one. Same thing, should it be circumcenter or incenter? So what are we doing? Marching band director wants a soloist to be the same distance from each side of the triangle. All right, so each side would be incenter. That's what you would need. Angle bisector. At that point would be equidistant to the sides. Okay, so if we do it in red, a perpendicular and a perpendicular, not a perpendicular bisector, perpendicular. All right, so incenter, and that's your homework.